NASA is about to send a command so risky, it could either extend the life of the most distant human-made object in existence or silence it forever. And the craziest part is, this isn't happening near Earth or even near the outer planets. This is happening 15 billion miles away, about 24 billion kilometers from home, where every single message takes 23 hours just to arrive. No instant feedback, no quick fix, and absolutely no undo button. One wrong move, and Voyager 1 goes silent. But if everything goes right, NASA might buy it a few more years of life. Enough time for one last miracle from a spacecraft that was never supposed to survive this long in the first place. Because Voyager 1, launched in 1977, is still out there, still moving, still communicating, still exploring a place no human-made object had ever reached before. And right now, it's dying. Not because of a crash, not because of damage, but because of time itself. A slow fading of power, a shrinking energy budget, and a machine that is simply running out of the ability to keep itself alive. But NASA has a plan. They call it the Big Bang. And despite the dramatic name, it's not about the origin of the universe. It's about rewriting the final chapter of a 49-year-old spacecraft, drifting in interstellar darkness. Voyager 1 has now been flying for nearly half a century. It is officially the farthest human-made object from Earth, further than anything else we have ever built. It has already left the solar system, crossed into interstellar space, and entered the vast, silent region between stars, a place where sunlight is just a distant glow, and the sun itself looks like nothing more than another star in the sky. But Voyager 1 didn't stop when its original mission ended. It was only meant to fly past Jupiter and Saturn, take a few breathtaking images, send the data home, and fade away. That was the plan. A short mission, in cosmic terms. But once the flybys were complete, Voyager 1 just kept going, past the outer planets, past the Kuiper Belt, past the heliosphere, that giant bubble of solar wind surrounding our entire solar system. And then, in 2012, it crossed the heliopause, the boundary where the sun's influence ends and true interstellar space begins. No spacecraft had ever done that before. Voyager 1 became history's first interstellar explorer, and it did it using technology designed in the early 1970s, running software smaller than a single modern photograph. Its power source is something almost poetic and terrifying at the same time: a radioisotope thermoelectric generator, or RTG. Instead of solar panels, it uses the heat from decaying plutonium, converting it into electricity. No recharge, no sunlight, just the slow decay of a radioactive element, producing a tiny but steady stream of power. And that's the problem, because plutonium doesn't last forever. Every year, Voyager 1 loses about 4 watts of power. That might sound like nothing, less than a dim household bulb. But when your total available power is already extremely limited, losing 4 watts every year becomes catastrophic over time. And that time has now arrived. On February 27, 2026, NASA's Jet Propulsion Laboratory sent a routine command to Voyager 1 for a simple roll maneuver to calibrate its magnetometer, a task it had performed many times before. But this time, something went wrong. The spacecraft's power levels unexpectedly dropped. Not a total failure, but enough to raise concern at mission control. Voyager 1's undervoltage fault protection system, designed as an emergency survival mode, can automatically shut down systems if power gets too low. However, if triggered at the wrong moment, it could disable critical functions and leave engineers needing weeks to recover, or potentially lose the spacecraft entirely. NASA had to act fast. On April 17th, They sent a command that took 23 hours to reach Voyager 1 and another 3 hours and 15 minutes to execute. When it finally ran, one of its last active instruments shut down, the Low Energy Charged Particles Experiment, or LECP. It had been running since 1977, collecting 49 years of data on ions, electrons, and cosmic rays at the edge of interstellar space. It didn't fail. It was turned off simply to save power. Voyager 1 launched with 10 instruments, and 7 have already been shut down. Now, only 2 remain, a magnetometer and a plasma wave instrument. NASA calls the situation razor thin, because survival itself is now the priority. The spacecraft must stay warm, or its fuel lines could freeze, ending the mission instantly. Every decision is a trade-off between science and survival. NASA estimates Voyager 1 may have only about a year left without intervention. That's why they're preparing the Big Bang. Not a single command, but a full system-wide reconfiguration of the spacecraft's remaining power. Some instruments will be shut down completely, while others will be switched to lower power modes to stretch its life. The idea is simple but risky. Squeeze out every possible watt to keep Voyager alive longer. But at 15 billion miles away, with a 23-hour signal delay, any mistake becomes critical. Engineers can't fix problems instantly. They must wait a full day for results, then another to respond. NASA won't test the Big Bang on Voyager 1 first. Instead, they'll try it on Voyager 2, which launched just 2 weeks earlier in 1977 and is now about 13 billion miles away. It has slightly more power and a shorter communication delay, making it the safer choice. The tests are scheduled for May and June 2026. If Voyager 2 handles the procedure and everything looks stable, NASA could attempt the same maneuver on Voyager 1 no earlier than July 2026. If successful, they might even reactivate a small half-watt motor in the LECP instrument for one final glimpse into interstellar space. Meanwhile, Voyager 1 continues drifting deeper into space at incredible speed, on a trajectory no human-made object has ever reached before. It is approaching a distance of 1 full light day from Earth, about 26 billion kilometers, or 16 billion miles away. To put that in perspective, the Sun is just 8 light minutes away, while Alpha Centauri, our nearest star system, is over 4 light-years away. Voyager 1 now sits in the vast empty gap between them, where the solar system feels tiny and the stars feel impossibly distant. And yet, even from there, it still sends back unique data on magnetic fields and plasma waves that no other spacecraft can currently provide. Eventually, Voyager 1 will fall silent. Its instruments will shut down. Its signal will fade into a weak carrier wave, and even that will dissolve into the background noise of space. But the spacecraft itself will keep moving forever. In about 40,000 years, it will pass near the star system, AC plus 79 388, drifting about 1.6 light-years away. Long after Earth changes beyond recognition, it will still travel as a silent messenger from 1977, carrying the golden record. Right now, it's still alive, still sending data, still waiting for NASA's final decision, the Big Bang. Whether it succeeds or not, Voyager 1 has already done the impossible, leaving the solar system and speaking across interstellar space